Welcome, my friends. This is our ninth lesson. Last time we talked about ground state configuration, and now we're going to continue and talk about excited state configurations. Well, before I go into it, I want to just give you a trick, because I want to lower the pressure. In a multiple choice question, you may be asked to choose which electron configuration is the excited one. And my friends, in this situation, it might be this simple. Just select the one that is not on your periodic table. Not on the periodic table. For example, if you found 2, 3 is on the periodic table, that's a ground state configuration. So you'd want to choose any of the listed configurations that you cannot find on the periodic table. All right, that's just a little trick. Now let's get into the depth of this. To review, what we did last time is we talked about ground state electron configuration. Oh, by the way, they're actually condensed, meaning that if you wanted to go to the full configuration, there's something called SPD and F. These are called sublevels. I can list my configuration in terms of the sublevels that make everything up, but that's not required on the Regents anymore. So we don't talk about sublevels. We merely talk about the individual energy levels, not the sublevels. If I have a configuration of 2, 3, let me do a little sketchy thing here. So here is our nucleus. We'll make this our first energy level, second, and third. So as I said, if I'm 2, 3, I have 2 electrons in the first energy level, and 1, 2, 3 in the second energy level. And by the way, these are all in their ground states. This is in the second energy level, but that's the lowest energy level that it can currently occupy. However, if this gains energy from outside, it can gain just the right amount of energy to make a transition to a higher energy level. So in that situation, I have to change my electron configuration. It's no longer 2, 3. What is it now? Well, I still have 2 electrons in the first energy level, but now I lost, so to speak, one of the electrons from the second energy level. So now I have 2. And now in that previously unoccupied third energy level, I have 1 electron. So a possible electron configuration would be 2, 2, 1. But by no means is that the only possibility. What else could it be? Well, let me reset my ground state. I've reset it. The boron is back in its ground state of 2, 3. Let's say a different amount of energy comes in, and it turns out it's just the amount of energy that one of these inner electrons has to be bumped up to the second energy level. Well, in that case, I have to rewrite my configuration like so. I lost that electron in the first energy level, and now it's been boosted to the second energy level. So now, here's another possible configuration. Now I have 1 electron in the first energy level, and 4 in the second energy level. So notice, there really are an infinite number of possible ones. So in a part 2 question, there's more than one correct answer. Let's move on to sodium. Notice we're using the same ground states that we arrived at the previous lesson. So originally I have 2, 8, 1, meaning I have 2 electrons here, 8 electrons here, and 1 electron here. Well, let's say, let's say again the second energy level, which is full. One of those electrons happens to gain just enough energy to make a transition to the fourth energy level. Well, I have to rewrite this then, don't I? That 8 now has to become a 7. And now that electron got boosted up to the fourth energy level. 2, 7, 1, 1. But of course, that's not the only possible one that it could be. I've reset the ground state, and, well, let's say that an electron comes, apologies, not an electron, energy comes, And one of the innermost electrons in the first energy level gains just enough energy to make it transition to the fourth energy level. Well, in that case, I would have to remove one of these electrons from the first energy level, and I'd have to promote it to the fourth energy level. So that would be 1, 8, 1, 1. But be careful, my friends. Sometimes students do this. They do this. They bring in energy, and they say, well, it's gained enough energy to go from the first energy level to the second. Then they say, as I've been saying, we need to rewrite this. I have to remove one electron, leaving me 1 in the first energy level, and I have to add 1 to the second energy level to make 9. Cannot be, my friends. Remember our maximum. In the first energy level, n, you can have 2n squared, you can have 2. In the second energy level, you can have a maximum of 8. 9 exceeds that. So that's not possible. Be careful about that. Lastly, vanadium. Remember vanadium from last time was 2, 8, 11, 2. Well, I think the easiest one to do is why don't we give one of the last electrons just enough energy to get boosted up to the fifth energy level. So that would be still 2, 8, 11. I lost one of these because it got pushed up to the last energy level. Well, what about this? Why don't I boost up? I'll give energy to one of the electrons in the first energy level, and I'll boost it to the third energy level. So that becomes 1. 8 remains 8. This gained an electron from the first energy level, 12, and 2. That's great. What else could I do? Well, how about in this one, I will give enough energy for one of these to get boosted up to the fourth energy level. So the 2 remains 2, the 8 remains 8. One of these electrons got boosted up, so this became 10. And this got one of the electrons from the third energy level, so 3. But be careful, what's not possible? Again, if I try to do this. If I try to boost one of these electrons to the second energy level, 1, 9, 11, 2. Guys, that is not possible. Just be careful. So great, that takes us through the ninth lesson. I'm lisping. We have one lesson left in the unit, which I will, before you know it, have up as well. I'll see you next time.